All right, welcome back. In this video, we're going to take a look at how to back up your Synology data to S3 Glacier Deep Archive, so let's jump in. So in previous videos, we looked at how to back up your data to S3, which is pretty simple using Synology's Hyper Backup application. However, we also looked at the cost implications of this and the fact that Hyper Backup doesn't use the cheapest S3 storage class. And just for reference, let me pull up on the screen in front of us the S3 pricing page. Now, Hyper Backup does have a number of storage tier options, and I don't recall all of them offhand. But if we just look at some basic pricing differences for S3 standard, your first 50 terabytes are charged at $0.023 per gigabyte per month. And I think the cheapest you can get with Hyper Backup, I think is S3 One Zone Infrequent Access, which is $0.01 per gigabyte per month. In the last video, what we looked at was we're like, well, how do we get to use S3 Glacier Deep Archive? I mean, look at the price difference on this. $0.00099 per gigabyte per month. I think the math we did showed like storing 5 terabytes was $5 a month versus $50. That's where we really wanted to get to. Now, if you want to use the S3 Glacier Deep Archive storage class, you're going to need to get a bit more hands-on, and it will require regular manual work and maintenance, and that's what we're going to show today. Now, first, before we jump in, a couple caveats. The solution is not for everyone. When you use Hyper Backup, you're typically running an automated backup job on a periodic basis, like daily, weekly, monthly, etc. And when the backup runs, it determines which files have changed and incrementally updates the backup. And this is the key point. In order to do this, Hyper Backup needs to be able to read the information associated with your existing backups so it can determine what's changed since then. And it can do that with normal storage classes. Like when you're using S3 standard, you can basically just do reads on that like they're files. The problem is you can't do that with the Deep Archive storage class. Once an object is stored in Deep Archive, you can't read it again without first restoring the object. And this process costs money and it takes time. I mean, it can take, I think, a minimum of 24 hours to restore an object and up to 2 days. Basically, kind of understanding the state of the backup is simply not possible. And so you need to think of Deep Archive as like write-only storage. And so if you have frequently changing data, this may not be a good option for you. But I think Deep Archive can be a good addition as a kind of layer in a tiered backup strategy. So personally, I obviously have my Synology. I have it backing up to a USB drive periodically, which I can take off-site if I want. I have it backing up to other machines in the house, like I have a TrueNAS system, right? In all those cases, it can do incremental backups and it's really quick. And I do have some data, low volumes of data backing up to a more expensive S3 storage class because I might want to be able to get those really quickly and I want the regular incremental backups. I treat S3 Deep Archive as basically like the worst case, something goes horribly wrong scenario that I expect to never use. What I do is I'll take all of my data and I'll back it up to S3 Glacier Deep Archive once or twice a year. And it is a manual process for sure. So I back everything up, I delete the previous archive, and off we go. For the type of data I'm storing, photos, videos, family stuff, in an absolute like horrible scenario, if I lost like a couple months of pictures, that wouldn't be the worst thing in the world. At least I'd have most of them. It has very specific constraints and use cases, but I do think it is worth understanding and considering in kind of your overall backup strategy. So let's take a look at how we do this. So first thing, if you don't have it configured already, you do need to enable not remote access, but you do need to enable SSH access to your Synology. So go ahead and do that if you haven't done it already. And for the purposes of this demonstration, what I've done is I've created a shared folder, which you can see here, and this contains about 90 gigabytes of iPhone backups. So this is photos and videos taken from an iPhone over many years, and I've set these aside just for this purpose. And it is, like I said, about 90 gigabytes. So it's certainly not small, but it's nowhere near kind of the 4 or 5 terabytes I would be storing on a regular basis, but it does serve as a good demonstration point. So how do we do this? So let's just pull up our SSH window. And the answer is we're going to rely on very old, time-tested, easy-to-use Unix commands, tar and split. It's that simple. So just to show you, here I am SSH'd into my Synology, and I am in, so volume 1 is the only volume I have on the Synology, and see I have my phone backup shared folder, which you can see here, and you can see where we are in the phone backup directory. And here are those directories. So pretty straightforward. So if you're not familiar with it, what tar does is, well, actually, I'll bring up another window. So there's no man pages on the Synology. So I have a WSL window here, which you can take a look at. And so it has a very descriptive introduction to what tar is, an archiving utility. So great. Basically what tar does, if you're not familiar with it, is it takes a whole bunch of files. It can be an entire directory structure, and it bundles them all up into a single file. That's it. Now, if you think about the days when, I think it literally stands for tape archive. So back in the days when you would back things up to tape, you basically needed to take all this, structured, directory structured data, and think about it as streaming it out to a tape where you're just writing a stream of bytes. And that's what tar effectively allows you to do, is create one file, which then you could stream out to a tape device, but we're just going to use it for its packaging purposes here. So let's just take a quick look at the information we have. So let's see how big it is. So like I said, 87 gigabytes, pretty big. Let's see how many files there are approximately. So approximately 62,800 files. So what we're going to do is we're going to tar all this up into one file. And you do that, it's as simple as this, tar. And we're going to give it a bunch of commands. Now, you can start with the -z option. And let me jump back to the man page here. And you can see the -z option filters the archive through gzip. And actually there are other options. If you want to filter it through bzip2, xz, whatever you want, it's up to you. So what you can do is as you're creating the archive, you can compress it. Now, whether or not you want to compress it is entirely up to you and really depends on the type of data you're storing. In the case of storing a lot of image, photo, video data, they're already highly compressed and you may not get a lot of benefit out of compressing them. And also the compression is going to add quite a bit of time to the archiving process. Now, if I were doing this for real, I would compress it, just because why not? It will get a little bit smaller and it'll save me on storage fees. But just to make things simple and faster today, I'm going to leave off the -z option. I will add the C option, which means create an archive. Now you can create an archive or you can extract one. In this case, we're going to be creating one. V is verbose. F is going to be the output file name, and we will call this phonebackup.tar. And then the next set of options is a list of everything you want included in the archive. So we will just say star. We're going to throw everything in there and we will let this go. Now, obviously, this is going to take a while, so we will come back when this is done. All right, our tar command has finished, so let's take a look. And you can see our very large 93 gigabyte tar file here. And so we can't really upload this to S3 directly. Well, we could, but you're going to hit a bunch of problems in doing this. So first of all, S3 has upload file size limits, I think of about 50 gigabytes. This will force you to move to using multi-part uploads, which complicates the upload process and your usage of the CLI. And I don't know offhand if the CLI supports multi-part uploads, but for me, it's just not something I want to deal with. What I want to do is kind of break this up into easier to manage chunks, and that's where the split command comes in. But before I go into the split command, you're probably wondering, like, wait, why don't you just upload all of these files directly? Like you can, like the AWS CLI is really easy. I mean, this is not a real command, but you could just do like AWS CP -R, and like you can recursively copy this entire directory structure up to S3. So why not just do that? Well, one of the reasons is the cost implications. So if we go back up here to the storage pricing page and we look at the footnotes, like this is a key footnote. S3 Glacier Deep Archive storage classes require an additional 32K of data per object. So every object you're going to store, which is every photo, video, etc., it's going to add an additional 32K of that for metadata. And you're going to pay for that. Since we are storing this in a storage class where we're not going to be accessing it a lot, to me, it's not worth the extra overhead of, managing 62,000 files and paying for the additional overhead of each. I don't expect to touch this data ever. Again, this is really like a disaster recovery if something goes wrong. I'm not going to have a backup program inspecting this and backing up differences. So I'd rather just keep it simple and kind of reduce the set of files I have backed up to some manageable set. And so that's why I don't just back up the entire bare directory tree. That's why I tar it up. So what we're going to do is to actually take this 90 gigabyte file and make it somewhat more reasonable, we're going to use the split command. Now, since we don't have man pages on here, we'll just take a look at split. And what split does is, as it says, it splits a file into pieces. So it outputs pieces of the file into basically prefixed files. The default size is 1,000 lines, but we're going to do it a little differently. What we're going to do is we're going to break the files up by size. And so we want to take our 90 gigabyte file, imagine it being terabytes, and break it up into some reasonable chunk size that won't take forever to upload each file, yet won't create so many files that it's unwieldy for us to upload. So you want to pick a number in here which is a somewhat reasonable middle ground. If I were uploading several terabytes, I may pick a size of, I don't know, several gigabytes, maybe like 5 to 10 gigabytes per file. Now, for the purposes of this demonstration, I'm just going to break this up into 1 gigabyte chunks because it'll be easier to upload and work with. So the way you do that is like this. So you say split, and we're going to do -B, and this is how we're going to break it up into sizes. And we're going to say 1,024 megabytes, 1 gigabyte. And this should do it. Actually, that'll work, and it'll create a set of prefixes. But what I want to do is I'm actually going to specify the prefix on the output, and I'm just going to call it phone back -tar dot. And so we'll let this run. And so this is going to take some time since it is going over 90 gigabytes, but let me just pull up another window so we can take a look at what it's doing. All right. And what you can see here is, so we have our original large tar file, and now here are the 1 gigabyte chunks. And you can see, remember I specified kind of the prefix of the file to be phone back -tar dot, and it just adds AA, AB, AC, AD. And so it's going to go off and work on doing that. And when it's all done, we'll come back and we'll show you how to upload those to S3. All right, well, our split is all done, and let's take a look at what we got. As you can see, the 90 odd gigabyte input file has been broken up into 1 gigabyte chunks using the prefix we specified and with a suffix of AA, AB, AC. The cool thing about that is when you actually list these, they will come out in the correct order. And if you want to put all this back together, you could literally just cat all of these files in the right order to an output tar file and then unpack the tar file. So now that we have this, let's upload them to S3. We are going to be using the AWS CLI Docker image, and I did a separate video of how to install and configure that. It's really straightforward, but I'm going to assume that is done. Let's just make sure that the image is working first. And so I actually just pasted in a command I had on the side. One thing I did mention in my video is sometimes it's easier to alias all of this to a simple like AWS command. I'm not going to be doing that in this case, so you can see what's going on behind the scenes, but that might make it easier for you. So this is our Docker run command. I'll be going through the parameters in a second, but let's just give it a quick test. Okay, looks like it works. Now, before we copy all these, we're going to need to create a bucket in which to store these. Now, you could create the bucket from the command line, but I am going to go over to the S3 console to do this. So here we have the S3 console, and you can see I do have another bucket where I was doing some other testing. So I'm just going to create yet another bucket. And so we'll call this, we'll call it Snore and Test Backup 2. We're putting it in the US East region. I mean, why not? Always block all public access to this. We're just going to leave the default configuration as is. And so we will create the bucket. Cool, so we have 2 buckets. Now if we go back here, if we run S3 ls as the command. Now just remember, when you run the Docker image for the AWS CLI, the entry point is the AWS command. So everything to the left of the cursor is effectively saying run AWS. So we're going to run AWS S3 ls. And there you go, we can see our 2 buckets. So what we want to do is we want to upload each of these files from the split command into this bucket. And what we're going to do is I'm going to start simple, and we will just upload a single file and just confirm that it works and show you what that looks like. So let me walk you through the command line parameters. So obviously sudo, we need to run this with sudo permissions, docker run, rm removes the container when we're done. We need the -ti option to fix some new line issues. And so the -v options are the most important ones. So these are going to they're going to mount volumes inside the container. And this is how we make the data that we're going to upload accessible inside the container. If you don't do this, you're not going to be able to see the data. Or more interestingly, if you copy data, say down from S3 into the container, and it's not copied to a volume which is mounted, it'll just be deleted when the container exits. So anyway, so -v. And so what this is saying is the .aws directory in your home directory will appear as /root inside the container. And the other thing we need to do is we need to make all these file parts visible inside the container in order to upload them. And so that's what we're doing here. We're basically saying /volume1/phone backup, what you can see above, right? You can see /volume1/phone backup contains all of the output from the split command. And so we're going to take that, and inside the container, it's going to show up under /data, right? And so then this is the name of the container. And so here is the S3 command. So we're going to do S3 copy and /data, because remember, we're executing inside the container. So we need to reference a container local file. And we're going to upload this first file. And now we need to give the S3 URL. And so we'll give the name of the bucket, Synology test backup 2. All right, and it is uploading. Now, we actually made one critical mistake with that. I don't know if you caught it. So let me see if I can cancel this. We forgot to specify the storage class. So not getting the storage class right defeats the entire purpose. And that is just another command line argument. So you do -- storage class equals deep archive. So let's run this again. All right, that's all done. So we should be able to go over to the S3 console now and take a look at that. So we'll go back here, we'll go into the bucket we created, and sure enough, there is the file. And here's the good news, the storage class is exactly what we wanted. So using that as a foundation, you can upload all of those individual file pieces. But now let's look at the workflow if you want to get one of these files back. And so let's go back over to the AWS console. So if we take a look at this particular file, you can see it says the object is stored in the Glacier Archive Deep Storage class. In order to access it, you must first restore it. So this is what we said before. If you want to do anything with these files, you need to go through lengthy restoration process. So let's take a look at what that looks like. So imagine like, hey, I want to get this file back. And so what you do is you come in here and look, I'm sure there are ways to do this through the command line as well, but I thought showing it on the console would be a little more illustrative of what's happening. So you do initiate restore. And what you do is you can either say you can do a bulk retrieval or a standard retrieval. Now, my guess is there are different cost implications of this. And then you ask for how many days you want the restored copy to be available. And this is important. So you can say 2 days. And then you specify which objects you'd like to restore. Oh, let's actually, while we're here, why don't we open up pricing? So here's the pricing on retrievals from S3 Glacier Deep Archive. And the standard is, so let's see, this column is data retrieval requests and then data retrievals per gigabyte. For standard, it is $0.02 for standard. That's the 24-hour SLA, or $0.0025 for bulk. So yeah, you're going to pay for that. But once you kind of find the objects you want to restore, you say how many days you want it to be available, and then you click initiate restore, and then you need to wait. We come back and you can say restoration is in progress, and you probably need to come back in 12 or 24 hours. And the key is that object will only be around as long as you specified, and you'll be able to download it using a standard S3 URL download. So if you want it to stick around longer than the time specified, you either need to copy it to another S3 bucket or download it within that period of time, or you're going to lose it and then you have to pay that request again. But I want to show you kind of what that looks like since I already went through this process. So if I go back to buckets, so this is a restore I did the other day. So you can see this one, I did a restoration on it. It says restoration is complete. And the restoration expiry date will actually be tomorrow. So I gave this 2 days. And then if I want to download it, I can just click download. And there we go. Now, again, this could also be done from the command line interface. So That's roughly what it looks like. Imagine worst case scenario, you're like, I need to get all this data back. You're going to have to go through that restoration process for every one of those files. Then you're going to need to wait a day or two. Then you can actually go do the download. Now imagine you've gone through all of that. You've done the restore, you've done the download, you're sitting staring at a screen just like this with all these pieces in front of you. So how do you get these back to a tar file and kind of complete the restoration process? And like I said, with Split, you can just do the inverse, which is cat them all together, and that'll look something like this. So first, let me just show you. If you just do ls, you get them in the right order. So you can just do, and then you redirect the output to restored back, whatever you want to call it. And there you go. And then you wait till this is done. And once this is done, we can extract the tar file. All right, looks like our cat operation is done. And so we have tar file back out of that. So let's just confirm this extracts. So let's do tar xvf restored backup. There we go. That's how you do it. And that wraps it up. That is how you can back up your Synology data to Amazon S3 using the Glacier Deep Archive storage classes. As I said at the top, definitely requires some manual work and regular maintenance if you want to go down this path. And I'm sure with a little extra work, you could script it to minimize the overhead. From my point of view, it's another kind of tool in the tool belt and a very, very affordable way to store large amounts of data very safely. So we'll leave it there. If you have any questions or comments, leave them below, and we'll see you next time.